Hi, I'm Christopher Plummer from Michigan Technological University, and I'm going to be talking about sound systems today. We're going to start with room acoustics and psychoacoustics in terms of how we hear and how we perceive sound to build models of how we design our sound systems. From there, we're going to look in depth on specific sound systems and how they use time of arrival to shape how we perceive the sound and keep the sound field focused on the stage to draw the audience's attention to the stage. And then we're going to talk about immersive audio systems, spatialization systems that make it a lot easier for us to shape that sound to quickly work in a multi-channel system where we're using 20 speakers, 30 loudspeakers, hundreds of loudspeakers, even thousands, to really make them all a coherent system that we can quickly program and still be creative on and not be overwhelmed by the technology, not be overwhelmed by programming each individual speaker every time we want to make a cool sound. In order to really understand sound systems and create a really immersive, transparent experience in which sound creates a world rather than comes from speakers, it's really essential for us to start with an understanding of room acoustics, to know how we experience sound normally. Once we have that, then we can fold that back in, we can refine it, and we can focus it on how we put speakers into a room and how we tune those speakers and how we focus particularly time to create the illusion of sounds in a room rather than sounds coming from a loudspeaker. So as we look at acoustics, the first thing we get is direct sound, right? So if we look at this diagram here, we have a person on stage, we have our audience member, and we have sound going from their mouth to their ears. Pretty straightforward. If we look at our room time plot down here, we can see that A here is our direct sound. It happens first. This axis is time. This is volume, amplitude. So we have loud and time. So the first arrival of sound is from the speaker's voice to us. Note that that is not T0. It takes time for sound to travel this distance. Approximately 1 foot per millisecond. One of the few things that makes feet measurements nice. So if we move on, we have early reflections. These are the next things that happen in time. And so we have a reflection off the back wall, reflection off the floor, reflection off the ceiling, back wall, ceiling, listener, there'd be one off the back wall to there, side walls, which, because we're doing a section view, we can't really see, but all of these discrete reflections off of surfaces. Now, obviously, how absorptive those surfaces are, it's going to make a big change in the sound here, right? And this is, the direct sound doesn't ever change, no matter what the room is, but these early reflections and then the reverb change a lot. And we know that that can have huge impacts on how intelligible somebody's voice is, how easy it is to understand what they're saying. So these on our time plot, you can see B, D, E, C, and so B might be our floor. Probably in this circumstance, the ceiling would be really close in time to B. You know, E might be this one, and then C is, it might be something that goes back wall, ceiling, back, rear wall, and then audience member. But we can see that those are going to be lumped in these early reflections. They're going to be fairly distinct as reflections, but they're going to happen in an early amount of time. We're generally looking at really interested in the first 20 milliseconds, but even up to 80 milliseconds, depending on the room that you're in, and a lot of other circumstances may be lumped into this early reflection system. Now we get reverb. So, as we looked at those early reflections, right, we've got this wall, then this wall, that wall, that wall, that wall, right? And then there'd be this wall, and then that wall, and then this wall, and then there. And at a certain point, we get so many reflections coming from so many surfaces that we can't separate out what is reflection and or where that reflection's coming from. And so in perfect reverb, the sound comes at us from all directions. It's dense and luscious and doesn't have anything sticking out. And so that's how we get this wash of sound here, right? Now, in the real world, we might be sitting close to a wall. We might be in an alcove where there might be directionality to the reverb. There might be some frequency anomalies. There might be some time anomalies, so it's not perfectly, wash and rise and fall. It's going to have an imperfect shape to it in our imperfect world. But ideally, this is kind of what we're looking at. And as we think about our sound systems, we want to work towards that ideal, not work towards, a flawed system, right? So if we just look at it from a technical standpoint and we start to think about how we're going to use this for speakers, we have a person on stage, we have these different reflections, and these reflections are represented in our time plot here, right? So C is really long, takes a long time. B is fairly short relative to the direct, right? It's the closest. D takes a little bit more time. E is a little bit more time. Now, as we look at sound systems, right, we put a sound system on the edge of the stage. We have a person on the stage. Note that the line for A is longer than the line for L. What that means is we're going to hear L before we hear A. This is going to be a problem. One of the key ways that we determine where sound is coming from is first arrival, is time. It's not how loud the sound is. It's how early do we hear it, right? So in this sort of setup, where we hear the loudspeaker first before the performer, our brain says the most important thing is the loudspeaker, not the performer. And so we don't really ever want to be in that situation. We always want to hear the performers first. And so the first thing we do is we add a little bit of delay to the speaker so that we hear this first and then this second. We don't time align this. We don't want to hear them at the same time because if our performer moves a little bit, that changes the time and we're not hearing it at the same time anymore. If in rock and roll, sometimes they'll time align the whole sound system to the snare drum, and that can work okay so long as the snare drum is exactly in the same place all the time. But even there, it's not bad to hear the snare first and then the sound system. And this brings us to a really important thing. How do we set this delay? So if we're going to set it with our ears, which is not is the ultimate arbitrator, very important, and also the slowest, least reliable way to do it. But you need to confirm everything with your ears. It's got to sound right. Don't trust your sound testing devices too much. Use them for what they're good at. So if we're doing this by ear, we're going to do this as a thought experiment where we won't ever actually just set things by ear. But if we are, what we want to listen for is not how is the timing. We're not listening for timing. We're looking at such small units of time that we don't hear it as rhythm. We don't hear it as attacks. It does, as we get this right, and it does really clean up the attack. It does clean up the sound. But what we really hear it is positional data, right? Our brain is hearing these, and it's trying to sort out what is the source of the sound and what are the reflections. How does the voice sound? How does the performer sound versus how does the room sound? And our brains constantly separate that out. So if we consciously engage all this unconscious processing that's going on, we can hear this much more reliably. And so instead of listening for the rhythm or listening for the clarity of the attack or listening for those sorts of things that are easy to think are the things to listen for, if instead we listen to where does the sound like it's coming from? What sounds like the source of the sound? Suddenly, our brain and ear system gets way more efficient. It's way easier to identify what's going on, and we can really zero in on our delay. And so if we have, we can set up a speaker where our performer is going to be, and then we'll have the speaker that's our PA speaker, our system speaker that we want to tune. We put sound through them, and if the sound is equal volume with this person, right, they're going to hear all of the sound coming from this speaker. As you increase the delay on this speaker, sort of moving it, which virtually moves it back farther on stage, we're going to pass a point where that image will shift to the performer speaker on stage because we hear it first. Right? And so the volume hasn't changed, but our perception of where the sound is coming from has changed. And so that is why time is so important in sound systems. It's called the precedence effect, and you've probably heard about that a lot. What we can then do is we can add more speakers, and we can start to really play with this. And we're going to use the precedence effect not just for this speaker, but for all the speakers that we're going to put in the space. So let's go a little bit more into depth on our different speaker systems, how we're going to shape sound, how we want to think about the aural space around the performance on stage. So first thing, stereo is bad. If I have a speaker on either side of the stage and I want really great stereo sound, I want panning, I want a good virtual center image, the only people that get that is this little strip of people down the middle. If you're sitting over here, you're going to localize to this speaker because that's where you hear the sound first. If you're over here, you localize to this speaker. Now, this is a big problem, right? Because if your performer's here, but you're localizing over here, your attention is not being drawn to the stage, right? Now, delay is going to help that, right? But as we do delay, we're still... this person's going to hear this speaker, not this speaker over here, because as we delay this speaker, it gets even farther away from this person and less important. It becomes more and more a later reflection in the room for this person's perception. So stereo just really doesn't work. We need to create a more immersive sound system that's going to use more speakers and that's going to arrange them differently. And we want to think about focus. So one of the first ways that we can go from our stereo system to something that might enhance our stereo system, because we're probably going to have two speakers either side of the stage. People are accustomed to that. We can get speaker locations there, and they do provide a really good foundation for everything else. But if we think about them as stereo, it all breaks. We don't want to think about them as stereo. We want to think about them as parts of the room. And so this speaker here, remember we had those reflections off the back wall, and if you're in a concert, you're going to have a reflector behind the performers, right? It's really going to help to get the sound out. But this, especially if it's if there's a reflective surface back here and we can reflect it off the back wall, or even a reflective scrim, if it's plasticky and reflects sound fairly well, that'll be great. If it's layers of duvetine, that's really soft, heavy curtains, it's not really going to be very good for us. But even if there's like a wall here, if we're reflecting off of here, it's still going to give us this big sound that's back behind the performer. And note that I've used this watercolor here because it's going to give us this diffuse sound. It's going to give us this, it's going to kind of fill the space behind the performer. Right, and so this isn't good. If I need a bird coming from a cage on stage, this is not going to do it. Or a telephone ringing or something like this. This is going to be this big kind of amorphous sound. If I need ambience, if I need sort of outside stuff happening outside an apartment, or we're at the park, or something where I need to create an immersive location, it's going to be great for that, going to be great for that foundation ambience. It'll be great for any underscoring, that sort of thing, because it just, that music's going to hold the performers, kind of. So we'll have the performer here, and then this big hug of sound that goes around them, right? It's beautiful. So put a speaker behind the performers, point it at the wall. Obviously, you don't want to send their microphone through that speaker, because that's just going to be feedback, and it's going to be indistinct and messy and not good at all. But for our sound playback, it's going to be great. So the other thing that we'll do, right, is we'll often have a center cluster, and we'll have front fills to go with this speaker at the back, right? And this is where we start to really get some useful stuff. Now, this, the center cluster and then the speaker down below, do seem, you know, is this going to have the same stereo problem that only people along this line are going to get good sound? If you use them wrong, yes, but nobody really thinks about these as a stereo pair, really, right? You're not going to take your stereo track and go, ooh, let's pan it left here and right here. Nobody does that. So usually, so there's less cognitive problems, less misuse of this system. And the other thing that benefits us here is our ears are on either side of our head, right? So horizontally, we have really good location capabilities. Vertically, we have less. And so if there's a speaker above the performer and then the performer, it's harder for us to differentiate those sounds. We'll still hear the delay, but because our ears are getting those delays sort of in, there's not an interoral difference between our ears, we have a little harder time differentiating them and saying, oh, those are different things. And so our attention is less going to be pulled away from that performer on stage. Also, if we go back here, if my speaker is here and my performer is here, the difference for anybody in the audience between the speaker cluster here and a performer on stage is a lot smaller than it is for a lot of people listening, you know, especially if you're sitting here, your attention is pulled this way and the performer is this way. I mean, that's almost, I'm looking over here, right? And the performer's over here, and that's really no good. Whereas that center speaker, in most cases, is going to be closer in line to where the performance is happening for anybody in the audience here. So that helps us as well. Front fills, same thing. They're going to be more in line with the performer and our seat. The next thing is that precedence effect we talked about, right? So what I want to do is I want to time these all so that I create this image here on the stage. This is where this dark cloud here is where I want the audience to think all the sound is, or all the sound that should be there, right? If there's things that are supposed to not happen on stage, they should sound like they're coming from elsewhere. But anything that's part of this world, and often if it's a proscenium show and we're really using the picture frame, a lot of my sound is just really going to be inside that picture frame. So I need to focus the audience here. We already talked about first arrival, super important for that. And so if I hear a person here, then I hear the front fills, then I hear these speakers up here, then I hear this reflection off of here. All of these are building up my early reflections, right? And so these are suddenly not just reflections off in different points in the room, but they're different loudspeakers, right? And just like I don't want to try and exactly time align these, I don't want to try and exactly time align these. I want to order them in degrees of importance, because as my brain hears later and later reflections that just emphasizes, oh, the performer's on stage, the important sound is on stage, and I can get my sound system louder and louder without drawing focus away from the stage. And I get more and more support from my performers, and it's just all good. So lots of speakers can actually sound less like speakers than only a couple of speakers. It's a way to make the sound system sound simple and disappear. And then I'm going to shade the amplitude on them so that we get pretty even sound. And, you know, if I only have these two speakers, I can create this sort of watercolor here where I can get some nice emphasis here, but I have no depth to that, right? With this speaker back here, suddenly I can pull this image back and I kind of get this triangle of sound that I can create. So what we're kind of looking at is conceptually thinking about our sound space as the area on stage, right? And this is going to be sort of our realistic area. This is where the performers are. This is where we want their voices to come from. Any practical effects, bird in a cage, telephone, you know, gunshot, things that happen as part of the action of the play, what in film is called diegetic sound. So sound the actors can hear is mostly going to happen here. Now, the actors may actually hear a horse race that's happening out here, or a car pulling up off here. So there is diegetic sound that leaves the stage. But for the most part, the world of the play is here, and there's this, and those sounds need to come from that world. Then, especially our underscoring, our ambience, needs to kind of hold that action, right? It's going to surround it. It's going to hold it there. It's going to support it. It's going to make us feel it, and it's going to draw us in there. And it's still going to be focused there because that's where the action is. That's where we want the audience to focus. If we have sounds out here in, you know, the back corners, our audiences, we don't want our audience to ever look away from the stage, right? We might want to have them feel immersed in the action. We might want them drawn into what's happening on stage, right? But we don't want them distracted, right? And so this, that's one of the reasons I use this much darker color for our immersive sound. And so we do have this sense of activating the full space, of immersing the audience, of making sure the audience feels like they're there with our performers. And the extent to which you use that does interact with the staging of the show. So if this is a proscenium show, the actors are all in here, it's fairly realistic. The amount of sound that's going to be out here is going to be minimal. Because we really want to focus on that action on stage, right? If you're in a black box theater and the performers wander through the audience, or proscenium and they wander through the audience, if those actors are breaking that, then the sound is going to probably break that differentiation between audience and set, audience and performance more as well. So this is one of the ways to, this is an actual sound system plot, and one of the ways to think about this. And so these are just subwoofers back here. We have some upstage speakers that are going to draw the audience. So audience is here and here and here. Audience attention is going to be drawn up here. And we have a little center cluster here that also draws attention up here. We have, these are basically our center clusters. So these audience members are attention is drawn here. This would have been probably nice. You know, it depends if, in this case, the action mostly took place here, right? So performers didn't push far down here. And so having this speaker up this way, farther upstage, worked in this situation. If this was, you know, if there was a wall here and the action was going to move farther down, then you might want to take these speakers D and move them this way so that the audience's attention is drawn more there. So thrust stages are a little bit more challenging. And then these speakers A, B, E, and F are all speakers that are pointed at the roof of the theater. In this case, the roof was pretty high. It was highly reflective. And so these speakers were able to just fill the entire space and give me this with just a few speakers. Right? If you're using a constellation system, if you're using other, Lexicon's got one, there's a few artificial reverberation systems. They often have tons and tons of speakers, and they really need that for that smooth, even reverb sound, right? To get that smooth, even, comes from all directions. I can't tell where the sound's coming from. You need a lot of speakers to recreate that sense of smooth, lush, dense reverb. However, if you have a suitable space and you can use the reflections in the space to get this speaker to just spread its sound like all over, and for it, and the roof there was a lot of girders up here and a lot of other things that broke up the sound. They diffused it, and so it gave me tons and tons of reflections and space-filling sound from this one speaker. And so if you can, just like that speaker I had that was pointed upstage against the upstage wall, and that spreads the sound more to point it away from the audience, can give you more room-filling kind of sound, can get you this sort of artificial reverberation system on the cheap, right? So it might fit in the budget much better than a super expensive system with hundreds of loudspeakers. Instead, I'm just using, 1, 2, 3, 4, 5, 6, 7, 8 speakers. And that works out really, really well in this space. Not all spaces are conducive to this effect. And so here you can see how high that ceiling is. Here's the audience down here as the normal door height. And so in these spaces, they've got a fair amount of space before the sound hits the ceiling, so it's already going to spread out fairly far. And in this situation, you don't want speakers that are too highly directive. You don't want them too focused. You want them to really spread the sound. So this is a black box, and so in this situation, the ceiling in this space is highly absorptive. So I tried this technique when I went into the space because I didn't know that the ceiling was highly absorptive, and it sounded awful. It was really, really bad. So rethought that, redid things, and so we have speakers 1, 2, and 3 are again sort of the center cluster idea, and so they're drawing, the audience's attention is drawn towards the stage. These speakers just point right directly at the audience members. We have these speakers, which are pendant speakers that are hanging down and just pointing straight down onto the audience. And then we have a series of speakers on the walls that's creating our reflections off those walls. You'll note that these all have milliseconds, and so 0 milliseconds is the actor reference. So I put a speaker right there. I want everybody to focus on that speaker. I want that to be the source of sound for my entire sound system. I'll hear these speakers 10 milliseconds later. The ideal sort of window for an early reflection, based on Floyd Toole's research, in terms of a reflection that gives us the most pleasure, it increases the size and width and naturalness of a primary sound, is from 9 to 12 milliseconds. That's the window for a really great reflection. That's where we get the greatest ability to turn the volume up, but not have it pull away from the focus. So if you want to turn your sound system up loud and still have the focus on the stage, or the first arrival, 9 to 12 milliseconds. So then I'm going to use that same sort of 10 milliseconds. So this is the next speaker I want to hear, right? So it's still in line there. And then we're going to add 8, and we're going to add another 8, and then some more. And so you can see that I'm going to have these first reflection, second, third, fourth, fifth, sixth, 7th, 8th, right? And so all of these, even though this is coming from behind, it's still encouraging your brain to focus here because of that time of arrival. We really hear this as, hey, it's a big room, there's sound coming from back there. And then as especially if I'm miking these actors, I can bring that mic up and it just sounds like a really good singer in a great sounding room, and that there's no sound system. So when we're shaping a sound system around the virtual acoustics of a space, one of the things that happens is we start to get a lot of speakers, and that can be very difficult to manage. We don't want to have to program in every cue every specific speaker in our sound system. That's very time consuming. It pulls us out of the artistic process of just creating the environment, moving the sounds around, making it happen, focusing in on the artistic space rather than the technical individual speaker space. So in order to shift us into that artistic space to manage the technology, we throw another piece of very complicated technology into the mix, and that's a sound field processor of some form. I'm going to show you SPAT, but there are quite a few others from L Acoustics and Meyer Sound and D&B Audio Technic. There's 3 or 4 more. So I'm going to show you SPAT. Runs on my laptop here, and I can show you without actually having to be in a theater, which is something that I can't be right now. So this is the overview of SPAT. When you open it up, this is a system in a black box theater with 30-some loudspeakers. And what this is going to allow me to do is have just a few inputs here that then go and get processed in specific ways that I've predefined or that I define in a more artistic sort of way. And I can show you that in a second here. So I've got my upstage stereo, and that's basically going to give me 2 speakers that sound behind the actors, but in the stage space. I have an Ambisonics input, so if I have sound effects recorded in Ambisonics, I want them to fill the space. I can just put the this one's set for 4-channel Ambisonics B format, and so it just comes in and then it gets spread through the 30-some channels of my speaker system. I have big stereo, so instead of something that's focused in the acting area, this is wider and bigger and sort of fills more space. And so for more distant sounds, or so the ambience beds that are a little bit farther away, musical beds that are farther away, that I don't want inside the action of the play, but sort of surrounding it, that's my big stereo. And so I have 2 stereo inputs, but they don't go to stereo speakers. They fill the space. They are spatially oriented through a sound system that focuses attention on the stage. Individual speakers, so I have a sound effect that needs to happen in a specific place. I believe that this was the elevator sound effect. And so there was an elevator on stage, and we needed the sound effects to come from that location, and so we positioned it here, and that meant that it primarily came out of that speaker by the elevator, but it also was supported in this time and amplitude focused way with all of the other speakers. I have a reverb input here, which is a 5.0 input, so 5 speakers. It's spread throughout the space, and then this takes my surround sound reverb and ups it to the 30 speakers. So it goes from 5 to 30, and that's what this processor does. And then I have my vocal reinforcement, which is also running through here. It's centered on the stage, focused there, but uses all 30 loudspeakers to give a really transparent vocal amplification. So this is a B format input transcoder, and then we have the sources, and this is how they're going to appear in my room. So the room is where I define everything, and then I have outputs from my room this is the center brain. That's why everything comes into it and everything goes out. There's some fancy stuff going on here. And then I have my speaker output, and you can see here, these are all my outputs. These are the actual outputs, the speakers. I also have output 7.1 surround mix and output a binaural mix. And so these give me recordings of the show if I'm, doing streaming these days. That sort of thing. You can get a stereo mix, you can get binaural mix, which is for headphones. You can get a 7.1 surround mix, and you can just sort of add up outputs. And you can position these outputs so you get them from specific locations in your room. So if I open up my room, that gives me all of this overwhelming information. You can see over here that I've got a ground plan of my space. So these are, let's see, these are the seating areas. So we've got 3 rectangles here that are seating areas. This oval is the stage area. These are actually stairs that go up to a high platform here and stairs that come down. These, and then these are all speakers. You can see all these white lines are focused on my listener. So I define a listener in here. There's a number of different ways to process the surround sound information in this software. Some of them work really well with a single listener, but not well for a listening area. Others work well for a wider listening area, not so good, and maybe not as awesome if you only have a single listener. So you have to choose the right algorithm for processing your sound. In here, I then specify where all my speakers are in my space. And you can see that low front left, here's the XYZ dimensions, and then the distance from the listener and elevation, azimuth. And so I can actually go in here and edit any of these and move those speakers around. And actually, in many cases, what I do is I'll sit at that location there, and I can use my laser pointer and do some of this. Also, if I get my listening position and one speaker positioned, and then I drop my ground plan in here and my ground plans to scale, I can adjust the scale of my ground plan and get that so that my listener and my first speaker line up. And then I can just place all the other speakers, enter in their height, and boom, I'm good to go. So it actually is pretty quick to drop in all the actual speaker locations in here. It's a little bit clearer. You can see there's my listening position. These are individual. Each of these is a speaker, sound source. If I go to top front, so this is my elevation. You can see that I had specified this listening position as like the second row up on the seats. And so there's speakers that are actually on the floor and below me. And then there's speakers that are quite a bit higher than me in the space. So we can see those outputs. And then here's, so here's the Ambisonics input. And we can see all the meters for these things, big stereo. So this is my vocal input. You can see where that is. This is my upstage stereo. And actually, I have to zoom out here. This is my reverb input. See how this is placed all outside of the space? That allows that surround input to come in and use all of those speakers. And in every case, it's going to make a bigger sounding space than I'm in because I'm adding the reverb. And so this really helps make that work. And the thing is I can, so if I go to, upstage stereo, the individual speaker is actually underneath those speakers. So if I go to this vocal input, I can easily just drag this around. So it was there, so most of the action happens downstage with only a few things happening up here. And so sort of balancing that out, if I wanted to get fancy, I could have this one and then have another one for action that happens up here. Not all that much action happened up here, and we had limited programming time, so we had the first, so we dropped this in, and we didn't change locations for the two scenes that happened up there. So this allows me to, my vocal inputs on my mixer now is just one fader, but it uses all 30 speakers. I can drop something in QLab, play it back, and boom, it goes to my upstage stereo, fills up the space, but is still centered on the acting area. Done. I don't have to individually in QLab assign it to all 30 speakers. Really, really speeds my work, gives me a lot more power. I then have a couple of extra sends that go to my reverb processor. I'm running another computer that's got Altiverb on it, and I'll have a couple of different Altiverbs. This is a Convolution Reverb, so it allows me to choose actual spaces. And then I can tweak the settings there, and that gives me, and then that goes into SPAT as well. And so this will do surround and 5.1, and I can take that 5.0 is usually what I do because I don't need subwoofer action on my reverb usually. And so that 5.0 then gets mapped to all 30, 40, 400, however many loudspeakers in the SPAT software, and really creates a much more immersive experience than sort of a stereo reverb processor or whatever you might be doing in your DAW. And it allows me to dial in all kinds of effects, all kinds of spaces, all kinds of coolness during the show. I can be there in tech, and I can have access to the whole sound field, and I can work creatively. I want the sound to come from here, and I can just move that around. I can also automate this through an OSC plugin in QLab, so that if I want a sound to fly around, I'm actually just flying it around in here. I'm not trying to deal with, oh, I need it to go to this speaker and then that speaker and that. I'm actually thinking about where on my stage, where in this reality do I want my sound to come from? And so I'm working in an artistic context rather than a technical context. And so these tools, very complicated, take some knowledge to get them set up right. But once you do, really liberating as a designer in rehearsal to work quickly, doing very complex, incredibly immersive experiences.